Okay, so this time we're going to discuss or review on the prerequisite skills needed in understanding the language of set. These are the some terms. So we have here a set. When we say set, it is a well-defined collection of objects called elements that share a common characteristics. A set is well-defined if the elements in a set can be specifically listed. For example, we have the set of flowers, set of animals, set of books. We can easily determine the elements or listed specifically the elements. But it is not well defined, for example, when we say set of beautiful ladies, because it's hard for us to list down the elements or members of that set since maybe some person may disagree to us. For example, I can say that Maria is beautiful, but other person or others may not, because beauty depends upon the beholder. So, beautiful set of beautiful ladies is not well defined set. An example also is set of tall buildings, because the child group of tall buildings in a group of tall buildings, a child can say that that is very tall building, but for us, that is not tall one, because it depends upon on the way we look at the object. That is not well defined. So the set here is usually represented by a capital letter. The elements listed between braces and separated by the comma. For example, we have the set A. The first four letters of of the English alphabet. We have A, B, C, and then D. The elements A, B, C, and D are separated by comma, and they are enclosed in parentheses. This one. Same also, we have set C. C is written in capital letter. We have 1, 2, and then 3. These are separated by comma. At the same time, they are enclosed by braces. We have also here the word finite set. We have infinite set. We have null or empty set. When we say empty set, or when we say infinite set, infinite means endless. Or we can say that the elements of the infinite set is endless, cannot be counted anymore because of it is endless. We have also finite set. In the finite set, the members of the set can be easily counted. We can list down the elements in the finite set. All the elements can be listed. But we have also empty set. When the elements of the set or the members of that set is absent or absence of elements, that is an empty set. Zero element. For example, we have a set of carabaos inside the classroom. So there is no carabao inside the classroom. That is empty set. For example, we say that the set of negative numbers in a natural numbers. So since we cannot find any negative numbers in natural number, that is empty set. As long as we cannot list or we cannot state the element of that particular set, that is empty set. As we have now this one, example of finite set and infinite set with the description and roster notation. When we say roster notation, the elements of the set is this one, listed. Set of whole numbers between 0 and 100. We have here 1, 2, 3, and so on and so forth. We have until 97 and 99. The three dots here indicating that there is still elements present, but the elements are not listed anymore because there are plenty of members. There's plenty. It's hard for us to enumerate. But we have here 1, 2, 3. These are the elements of whole numbers between 0 and 100. We have set of even whole numbers. the elements are listed, but we have 3 dots indicating that it is endless. 0, 2, 4, 6, 8, and so on and so forth. Endless also. The the members of the set is infinite. And that's why it's called infinite set. Infinite sets. We have here the primary colors. So the elements are red, blue, yellow. It is enclosed in braces, and the name is letter B. It is capital letter. It is represented by the capital letters. We have here also the different symbols. Some of the symbols we will be using, we have this one, bar, translates to, that's that. We have here is an element of. We have here proper subset of, is a subset of. Null set, we have union of two sets. We have also intersection of two sets. So for example, we have here the some of the symbol is used. We have here element. A is an element of A. B is an element of set A. C is an element of set A. D is an element of set A. For example, also we have this one. A is A intersection B, meaning the commonality. There is a commonality between the two sets, meaning the elements present in A at the same time members of B. What are those? We have here A. We have in set A we found C. In set B we have also C. In set A we have D. In set B we have D. In set A we have E. We have also E. So the three elements are present to B at the same time. It is found also in A. It is what we call intersection of the two sets. We have also here B union C. We combine all the elements of B and then C. The symbol is this one, B union C. This is B union C. So we have, we combine all the elements of A and all the members of C. B rather, B and then C. The elements are, we have A, A, B, C, A, B, C. We have D, E, F. So the elements of the two sets are combined. We have also here, C is a subset of A. By the way, this is a proper subset since we have C, we have all the elements of C. C, A, B, C is found in set A. Set A, B, C, D. As you can see, A, B, C is here. A, B, C is found in set A. So C is part, the members of set C are also members of set A. We call that C is a proper subset of A. C is a proper subset of A. We have here some of the special names of the numbers. Symbolic names. So we have Z stands for the set of integers, 0, positive and negative numbers. Integers rather, negative integers. So we have N, the set of non-negative integers from 0 up 1, 2, 3, and so on and so forth. Or this is also called whole numbers. We have also this one, Z exponent plus sign. That is indicating the set of positive integers. We have also Z exponent negative sign. That is the set of positive integers. We have here R, set of real numbers. W, set of whole numbers. Q, set of rational numbers, including terminating and repeating decimals. We have Q prime. Q prime is this one, set of irrational numbers. We have C, set of complex numbers. Those are the symbolic names that we'll be using in this set, language of set. These are the, for example, we have here, the set is written in set builder notation. We use here descriptor and we have the condition. So here is the proper. This is the property where the elements could have. Okay, we have here type of number. Okay, R. In this example, we have R. Stands for real numbers. The possible elements of this set are real numbers. The real numbers, so that are, we have here x is more than or equal to 3. The real numbers that are more than or equal to 3. What are those? So that is infinite. So we have here. So we're going to start from 3. Okay, 3. The 3 here, there is a circle with shade, meaning 3 is included. 3 is part of the group. So 3, we have the numbers between 3 and 4 is also part. Those are more than 3. 3, 4, up to, and so on and so forth. All the numbers here can be a member of that set. From 3 and above. All the real numbers, even the 1/2, even 3 and 1/2, and so on, all of those are members of that set. In interval notation, it looks like this one. This also can be written or described using the interval notation. Okay, for example, describe the set. So same, we have set builder notation. The x is an element of real numbers such that x is more than 0. Set of all x, element of real numbers such that x is more than 0. The elements that are more than 0, so we're not going to shade a 0, indicating that 0 is not part of the group. It must be more than 0. So 0 will no longer be included. 0, the shade of the circle has no shade, indicating that 0 is not part of the group. So we have here circle, and then we have this one, open interval. So it is from this point, from this one up to infinite. All the numbers more than 0, that are real numbers, those are the answer, members of that set. Describe the set. So the same, we have here the written in set builder notation, same. It is real numbers. Set of all x element of R, real numbers, such that the x is more than 2 but less than 6. It is between 2 and then 6. Between 2 and then 6. So we have 2 and 6. 2 and 6, there must be no shade in 2 and then 6. And all the numbers between those 2 points are the possible members of the set. So we have here, as you can see now, that we have 6 and 2 has no shade, indicating that 2 and 6 is not part of the group. But the members of the set are the numbers that are found at this segment. All the numbers, infinite numbers. We have also here described the set. So here, as you can see now, that the set type of number now is no longer real numbers, but say stands for, as we have said a while ago, that it is set of integers. Integers can have negative numbers, 0, and then whole numbers. So we have here, what are the possible elements in the set? But even though it is integers, we have still condition. The condition is this one. The element must be less than 6 but more than 2. So how can we show that how can we describe that set using this number line? So let's have this one. So as you can see now, that there are 2 and 6 has no shade, indicating that they are not part of the group. It is more than 6, it is less than 6 rather, but more than 2. Mababa sa 6. So we have 5, we have 4, we have 3, we have 5. All of these numbers, 3, 4, 5, are less than 6, and all of these numbers are more than 2. They are now the member or elements. They are members or elements of that set. 3, 4, 5. Okay, that's all for today. Thank you very much. And this will be used in discussing the part 1, part 2, part 3, and part 4 of the language of sets. Thank you and God bless.